Ethan has been a special guest at our events a number of times. If you have been to any event in the past, he's been a speaker and he speaks very well, right? Yes, I got a thumbs up over here. So you're in for a treat. I specifically asked to chair this room, so I'm here to hear him as well. Ethan is a senior engineer at ReviewTrackers, where he develops web application services to analyze consumer reviews of businesses using a variety of languages and frameworks. Outside of work, he spent much of the last year experimenting with large language models, particularly how they can be employed in software development. He is also an adjunct instructor at UC, but based in Chicago. Welcome, Ethan.
Cool. So I think this should be really fun. This is my second time at the symposium. I was here last year, and it's really nice because I feel like everybody, there are some other conferences that are different in tone than this one, where people aren't quite as social, but here I feel like everybody's always really excited to hear things and everybody wants to chat about what they learned, so it's nice to be back. I am excited for this talk because it's kind of a personal, almost a hobby project of mine. I think we're kind of on the bleeding edge of something changing in the way we program. I think everybody's noticed we're on the bleeding edge of just the way the world is changing. Like the main technology we're going to experience over the next 10 years is probably what we've seen over the last year and a half with artificial intelligence and generative AI. So I want to talk about how I think that's going to affect programming as a job. So before we get started, I'd be interested to just get a breakdown of like what people do. So how many people are students? Could you raise your hands? Okay, it might be like a third to a half. And then everybody else is in industry? How about industry? I'll think if there's any other categories. Okay, academia, non-students? Handful too? Okay. How many people have used ChatGPT? How many people have used ChatGPT in the last week?
All today.
Wow. Okay, so I think we have some enthusiasts. Good. Well, I don't know. Maybe you'll know everything I'm going to talk about. We'll see. Yeah. Also, I realize it's after lunch, so this will be a pretty chill talk. If anybody attended my talk last year, it's a pretty casual style, so we'll try to keep this very informal. Also, I have the slides. I have this link on Bitly, so you should be able to pull up the slides. I haven't actually tested to see how this works, but I think you should be able to view only the slides. If you can edit them, please don't. That would be just wrong or surprising. All right, so let's just jump into it. One other thing I want to mention just before we go is this talk is being recorded. I think a couple of the talks are at the symposium, but I just want to mention that so your questions and stuff might end up being recorded. Just a heads up. All right. So really, if you want to leave after this slide, that would be okay. The main point of the talk is that if you haven't used AI tools for coding or you haven't done it very much, they are an absolute game changer, way more than you might expect. And I think people, you can get a variety of hot takes about this topic. Some people get frustrated because they don't solve very particular problems, but they solve enough problems that they're going to change the way most people write code. I think that is almost indisputable for anybody who uses them for a significant amount of time. They absolutely nail a couple things. And the big two are unfamiliar programming languages. So a situation we end up in reasonably often is language handovers in data science. So if you have a data science team that works in R and an engineering team that wants to put that into production in Python, that's a divide. You sometimes, Apache Spark is a very popular data engineering tool. Some things in Spark require using the language Scala instead of Python, even though data scientists are unlikely to know. So there's these cases where you may not always know the language that you need to use for something, but you've already written the code in a different language. Translation between languages is something that these models really excel at. And another thing is repetitive code. So if you think of really repetitive business logic where you say, like, if this column contains a certain value, always remove it from the data, and then that's in your code many times over, it'll start guessing that. Your tests, if you have tests for software, are often really repetitive. Often they set things up the same way, they make the same kind of assertions, and those are the kinds of things that these systems are great at. Now, what frustrates people is that they're really bad at anything novel. Anything that there's no pattern for on the internet, where there's no pattern for in your code already, they are awful. I mean, they don't have any context about what you do at work all day. They don't know any of your supervisors. They have no idea what your company does. And so you can't ask them to anticipate things like that. They can only learn from patterns they have seen, which is obvious to say as a sentence, but I think people sometimes aren't thinking about this as they use the models. So we're going to talk about some more specifics. I've geared this mostly to be pretty practical. I have a lot of recommendations for if you write code, what you should be thinking about as you write it and how you should use these. But I also have some more general recommendations about thinking about the future of the industry, things around hiring and career as an individual contributor. So we'll get to that as we go. First off, a little bit about me. So I've worked in a lot of different places, not a lot of different companies, but a lot of different sorts of things. So I work at a company called ReviewTrackers right now, which is about 100 people, but we're actually owned by a conglomerate as of pretty recently. So there's some big company and some small company parts of that. It's interesting to see life at a startup because you tend to tackle a lot of different tools. And that's pertinent here because I do write in a lot of languages. At work, I write in Go, Ruby, Python, and JavaScript. At home, I do a lot of personal projects in Python and Rust and sometimes Go. So it's just kind of nice to have a system that can help me learn new languages really fast, which is one of the things that I've been able to experiment with using LLMs. I previously worked in data science at 8451. There's some 8451 people in here I saw. So it has kind of colored my perception of some of these tools because the practices that are pervasive in software engineering are not always so common in data science, things around testing. And so a tool that can make something like testing a lot easier can actually bring some of these best practices from software engineering into data science, which I think is something we need. Having seen the industry, that's something that's a lot less common than it probably should be. And I'm also based in Chicago. I'm also an adjunct here. I don't really teach classes much anymore. It's kind of tough to teach remote. But I've been around UC a lot, and so it's kind of fun to be back, honestly. All right, so here's our plan for today. I want to just talk about the AI assistants overall. It seems like most people are pretty familiar, but I just want to contextualize just in case. And then we're going to talk about specifically where are all the places that LLMs can really drive some kind of either like speed improvement or performance or quality improvement in your code. After that, a more tangible section on what should you think about doing as you work with them. And the last one is the things it's really bad at, because as I mentioned before, it is pretty bad at certain things, and staying away from those can make a big difference. So my experience with large language models and coding obviously has all come within the last year, because I don't think anybody's has been longer than that, unless you like work at Google or OpenAI. But I will say I find them so fun to work with, and they improve the kinds of things I can do so much that I use them a lot. And I think if you haven't done that yet, it's really worth experiencing, but I'd like to make the introduction a little easier than it might be otherwise. For me, there was a lot of banging my head against the wall because there were a lot of problems that they didn't help me with. And I didn't really understand how to use them in the most streamlined way. So hopefully when we finish this talk, you all will have a better sense of how you will do that. All right. So there's three kinds of AI assistants relevant to coding. There's chat. So it seems like everybody, almost everybody, has used ChatGPT. It's all over the news. My parents know what ChatGPT is, so you know it's not even cool anymore. There are other models, though, that do the same thing. So I think the biggest one I hear about is Claude by Anthropic, but there's like several other companies that are doing very similar things. So Google has Bard, and apparently, how many people have used Bard? Okay, well, I haven't, so I'm glad you guys have. Apparently they're rolling out like a much more powerful one in winter is the rumor, so it'll be interesting to see if that unseats ChatGPT. But right now, I think ChatGPT is pretty much the unquestioned champion of the space. Everybody knows what it is, that's the one everybody goes to. But there's also autocomplete, and the main one here, in fact, it is so much more dominant even than ChatGPT that I'm not sure about any alternatives that are in use, is GitHub Copilot. How many people have used Copilot? Just a handful. Okay, well this is a game changer. So I'm kind of pleased to see people haven't used it because it is so fun to see what it can do. And the last type is static analysis. So static analysis tooling is a general term, not related to AI. It's about what can we learn from code without actually running it. That's why it's static. Analyzing the code without running it, which would be dynamic. It's static analysis. Static analysis tools historically are really big for things like security. There is a tool called SonarQube. I don't use it, but it's like for scanning essentially the code you've written to see if it has vulnerabilities. This is really common in industry. But increasingly, there are static analysis tools to look at your code using AI and make some, using AI. I guess everything's AI in some sense. But in this case, they usually use LLMs. and draw some inferences from it and tell you like this is a problem, this is not. I haven't used these. I don't have a lot of use cases for these. A lot of my usage has been in my free time, and security vulnerabilities of my like toy web app is not a huge deal to me. But also I think these are just not as mature yet. So I would keep an eye on those in the future. But today we're going to talk about autocomplete and chat and how those can impact your day-to-day. So starting with chat. The idea of chat, just as it is in real life, is that it's a conversation between at least two people. In the case of AI chat, it's always going to be you and the chatbot. If you use ChatGPT, there's two tiers. And a tier in ChatGPT world really corresponds to what model you're using. So each of these artificial intelligence entities is a model in the background. There is a server running somewhere that when you send it a message, runs your message through essentially a predictive model, a pattern matching predictive model, and spits back out a likely response, a feasible response. And that's what's happening whenever you talk to it. OpenAI, the company that makes ChatGPT, has two tiers right now. One of them is the model that they've optimized for cheapness. It was like the state-of-the-art model for a while, and then they started, instead of improving on it, they started just trying to make it cheaper to run, and that's GPT 3.5. So if you log on and you don't have an account, you don't have a paid account with them, you will get 3.5. If you have a paid account, you get GPT-4, which is slower and more expensive for them. I mean, if you pay for your account, you don't pay based on usage, you just pay $20 a month. It's slower and more expensive for them, but it is much, 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 much better at problems that require a lot of context. And so another thing I want to emphasize in this talk is that a lot of the inferences people are drawing about what GPT can and can't do is based on using the free model, because most people don't shell out $20 a month. But actually, if you use this for your job, $20 a month is nothing. So what I will be talking about is GPT-4, and I also have a paid subscription, so we can, as we have some time in between slides, and maybe at the end, we can actually toy around with it if people want to see. But GPT-4 has a few advantages. I mean, we don't know exactly what's different about the model as outsiders. But one of the most important things is that the context it can take into account is much greater. So there's a thing called the context window in the way these models work, which is how many tokens, which are sort of like words, it can look back through the chat. And GPT-4 has a big advantage there, which is helpful because it means that it can remember a whole conversation. It can remember, you could summarize an entire legal document of a few pages, whereas GPT 3.5 has a smaller context window. And you can actually pay for an even bigger context window, but unnecessary for a lot of the things we're going to do. So ChatGPT looks like this. Here's two actual questions. All the stuff I think almost all, at least, of the things that I have for this talk as examples are actual things that were just in my chat history. I was like, I don't want to have contrived examples. I think I should just go back. I use this all the time. Let's just see what it has to say about some things. So recently I was kind of wondering why cars have transmissions. I'm not a big car guy, don't know a lot about it. So I was like, can you just explain? And it did. And it went on and on, actually. This continues, well down the page. And I don't know if anybody here is a car person. I assume this information is correct. It all makes sense to me, but as is always the case with these things, you probably want to double check if the stakes are super high. And another one was, how much can I put in my personal IRA every year? For those of you who are students, an IRA is a really boring part of adult life where you lose some money and you don't see it again for 50 years. So I asked ChatGPT about that. And, hopping back to something more fun, this is ChatGPT. And I realize it's small. Pop it up a little bit. I was writing some Scala code earlier today, and I don't know Scala really well, so I was asking it some questions about how I might do something. So this is real life stuff. You can see over here you have all your conversation history, on and on and on and on and on and on. I use it a lot. One thing that happens when you start a new conversation is you can choose right here, GPT 3.5. Fastest model, great for everyday tasks, available to everybody on all the tiers. GPT 4, available only to people who pay. You are technically only allowed to send 50 messages every 3 hours, but they don't actually enforce that. Usually it's only if there's a lot of traffic. And there's also plugins for this. You can plug in their image generator, which I haven't even used yet, so I'm not going to risk that during this presentation. And you can have web browsing. There's a couple other plugins you can install. So GPT-4 has a lot more features, is really the headline there. And it basically just works better. So this is what the web portal looks like. There's also an API, meaning that you can basically send messages from a programming language. We're not going to do that today. That's mostly how people integrate this stuff into software they're building for themselves, not what we're doing now. All right. So the other thing that we're going to talk about today, not chat, but autocomplete. This, it seems like people have less experience with. GitHub Copilot is the main offering for this. So GitHub, if anybody's not familiar with GitHub, GitHub is a place on the internet where you can store your code. You can almost think of it as like a computer where you keep backups of all your code, but it supports additional features because GitHub is based on a tool that's been around for a little over 20 years, I guess, called Git. And Git is a version control system. Version control means you have the ability to look at old versions of what you've done and to even create what are called diffs to see like what has changed since the last time I looked at this. So as the keeper of everybody's code, GitHub also has a very generous free tier that most people use for their code. GitHub has like just an unparalleled access to see people's code if they wanted to, say, train a large language model on it, which is exactly what they've done. So GitHub Copilot is the main autocomplete tool that people use. You can plug it into all sorts of different code editors. We're going to see it in VS Code, which is what I use for most of this talk. And it is, as you might expect, based on autocomplete, it is just something guessing the rest of your line. Now, what's funny about autocomplete, I think, is that all of these technologies are just autocomplete ultimately. It's not, when you use chat, it feels like conversing back and forth. But ultimately, this is a model trained to predict the next word, just like autocomplete always is. It just happens that they have optimized it for completing the next word in a conversation. So really, in some way, autocomplete is like the more raw version of what ChatGPT is doing, sort of looking under the hood. And some cases here that you can look at of autocomplete working. You have these short ones where it's like, I have written two very similar structures in a language. This is Scala. And it can guess, based on the structure of the first item, that when I start a new line in the second item, it thinks, oh, probably you're going to try to do this thing. But it's smart enough to know you can't do it because whatever I was doing on the first line, I was doing something with children and item. There are no children and item elements in this second thing I made, so it says you probably actually want to raise an error. So it's pretty smart. It's seeing a lot of the pieces. It says, I think you're going to try to write the same method, but it doesn't actually make sense on this other thing, so I guess the best guess is to just throw an error. Now, it's probably going to be wrong a fair amount of the time. Sometimes I have my own idea for how that's going to work. But sometimes it's right, you just hit tab and you move on, and it's just like, boom, we're flying through this, which is very satisfying. This one I think is even more amazing. In case you haven't guessed, sorry, I should have said, the light gray text is what's being autocomplete. The rest of it is what I've typed, autocomplete comes in. This is pretty cool. If you write a function definition for something that is pretty straightforward, that it's seen before, and give it a good name, it can often guess how to do the whole thing. I just wrote geometric average is a Python function that takes in this argument and returns this return value, and it just filled in the rest of the code. If I hit tab here, it would just populate, and that would be that. And you notice it's using all the right names. It's using nums. It's using, well, I guess there are no other names actually in this one, but it's using nums. And this function actually is correct. So it's pretty mind-blowing sometimes. For certain things, it's not like typing takes that long, but it is a bit of a time waster when you already know exactly what geometric average should do. You almost wish you could just like import it from some kind of code library. Well, you don't even need to. It just writes it for you, you're done, you move on. Okay, so those are the assistants. See how we're doing in time. So we're going to talk through a couple of specific areas where AI can really help us. And I've previewed a few of these at the beginning, so we'll move quickly through these. So learning new languages and frameworks, it's really, really good at. Because often what you're doing when you learn a new language is you're writing the most basic kinds of things. So if you're practicing you're picking up Python, because you use R a lot, you might practice doing like a linear regression in Python. Well, that's been done 10,000 times, and it's going to just nail it, especially if you start typing and you say like, if you start doing something with the data frame and you call one of your columns target, it's immediately going to infer from the fact that you use the word target that probably this is a regression problem. Not always, but usually it is pretty good at that kind of stuff. So as you're picking this sort of thing up, it's going to make some guesses that can basically speed it along. I think we have enough time that I can actually demo. Well, this is actually how you get Copilot going. Oh, I'm not sure. Sorry, one second. I gotta log in. Okay. Okay. So we're just gonna make a new file and not do anything else with it, not save it or anything. But we're gonna make this a Python file to make sure that VS Code knows what it is. We're gonna put this up here. Okay. So let's say we are working with, and I don't have actual data we're gonna work with here because I wasn't sure we'd have time for this kind of thing. But let's just say we want to write a function that's like build linear regression. I should turn off my words so that doesn't happen again. You see, already it's guessing. This is actually one of the downsides, and we'll talk about this a little more later. Already it's just going to guess anything. It's like, there's always some best answer, even if the answer doesn't have a high probability. Because, and this is a little bit of a tangent, you have to think that whenever it's making guesses about anything, it's guessing what is the next word, and then what is the next word after that, what is the next word after that. The probability of any word following any other word in English is still pretty low. There's certain sentences where it might be like, if you know the end, the punchline to a joke or something, sure. You can predict the next word, the next line. But in most cases, there's a huge degree of variation in language. And that is less true in code, but still pretty true. So even its best guesses might be like 5% right. And so it doesn't care if it's right like 0.01% of the time. Like the chances I was going to write this function are infinitesimal, right? Yeah, but it's going to keep guessing until I give it some clues. So what I might say is like, I don't know, we're going to call the function linear regress. Like we're building a linear regression on something. We'll say we have a features data frame, and it's going to yell at me because I don't have data frame imported. We're not going to use Spark. We have a target, and that is a Panda series. And we're not going to spend too much time getting every little bit of this right, but I don't know why it wants to return series. I don't do a lot of this anymore, honestly. But let's, here, what do we want to return? Probably want like, I don't know if I have scikit-learn installed. I should have thought this out before. I was like, let's just do a live demo. Sure. We'll save this, yeah. Okay, so one notable thing is you've got to delete all the code you have because it's going to do a really bad job guessing if it has all this old code here. So I'm going to now try again. And it is just going to nail the whole thing. It's just going to return the fit model. It's pretty cool. So it's just drawing inferences based on the fact that we called this linear regression and we pass in features of product. So this is the kind of thing where if you were an R user, and you were like, I just want to see how to do a linear regression, you could just write this function. And you don't even need to keep the whole function. You might eventually just, oops, I got a tab to actually complete that. But you might just rip out the pieces here. You might just like copy this and go back to whatever file you're working in and just paste it there. So for learning new languages, this is pretty obviously useful. Oops. Yeah, so this is very, very helpful for this kind of thing. Same thing goes for like new frameworks. So you've been working in Flask, which was a really popular way to build APIs in Python, but is recently kind of losing favor to something called Fast API. Well, you might just say, how can I do this in Fast API if I did it in Flask? And if you want to ask those kinds of interactive questions, which are common, sometimes I will go in here and say like, I'm used to building APIs with Flask, but I want to build one with Fast API. What's different? What are the differences to know? And, oh, this is cool. It's actually going to web browse for this one. So you can't always know if it's going to actually use the web browsing. In my experience is if it does, it's almost always useless because it's just really bad at searching for things. But it's cool. what I might do if I were actually asked this question is turn off web browsing, because it's a toggle you can have on or off and just see what it comes up with. But these are the kinds of questions where it will just come up with an answer and just tell you, like, well, here's the 3 things people say are hard to learn about Fast API and worth keeping in mind as you go. You can also have it translate code from one language to another, which also makes this kind of faster. We're going to come back to this in a bit, because this is going to take some time. Too many windows, I'm losing my presentation. I'm not happy with that. Ooh, actually, 1 second. Wow, okay. Sorry, getting lost over here, too many things. Okay, we're back. Another thing that can help as you go here is just adding plans and comments. And we're going to mention that a number of times as we go. Plans and comments are really helpful because if you just give a couple words of extra direction, it will no longer think you're trying to write the solve function, and it will realize you're trying to write the linear regress function. Sometimes if your name of your function is too generic, for example, it doesn't have enough clues to know exactly what goes in the rest of the function. But with a comment that explains like what you're trying to do, it will be a lot better at guessing. So here's an example of me doing some stuff in Scala. This is a lot like the example I just showed. But I just said, like, I don't know how to open a file. Can you tell me how to open a file and read the contents into a string? It just spits all this out. And what's really nice about it is it also spits out reasons. Not always. Sometimes you have to prompt it. This is the thing. It's not deterministic. But often it will explain the code in pieces. If you wanted to, you can just say that in the original question. Explain to me how all this stuff works. Very helpful. Also, I'm going to pull this back over because finally we finished browsing. Browsing, not a thing I recommend. It takes forever and it comes up with relatively bad answers. But it does have, you know, some thoughts on the difference between Fast API and Flask. Okay, another thing that comes up a lot is boilerplate code. So the example I have here, and honestly, Python is just known as a language that doesn't have a lot of boilerplate, but I wanted to stick with it for this presentation because I think it's probably the one that most people will be familiar with. But one example is, anytime you have a function that's going to open a file and do something, you're always typing the same thing, where it's like with open file name as if. I don't know if people have done this before, but it comes up a lot. And I would consider it kind of boilerplate. There's other boilerplate things about imports at the beginning of files. Often you're importing the same things in every file in your project, and it'll just start guessing those. Where this really comes up is if you ever have to drop down to like C to write Python extensions. C is an extremely verbose language. You have to specify the type of every single variable, and it starts getting that kind of stuff. I use Go a lot, and Go is really verbose because every time you do anything that could cause an error, you have to write this little snippet that's like, if there was an error, do this afterward. And it just gets that. So this kind of stuff becomes a lot less annoying, and you can run through your code a lot faster. Also, as I mentioned earlier, tests often have really similar structures. If you write a bunch of tests to say, like, make sure that my application or my model always does this, usually you're testing a bunch of different cases of the same sort of question. Like, does it do this in this situation? Does it do this in this situation? And so it can start guessing, oh, well, you're probably going to train this model, and then you're going to check what this column is, and then maybe you have to customize a little bit at the end of each test. But overall, it's pretty much the same. So it is very, very good at tests. I do a lot of API development. Has anybody done API development? I guess with models, you might. Yeah, okay. APIs are pretty repetitive because often APIs are used as like a way to send observations to a model to have them scored or make predictions over the internet usually. And so often you have to set up all this infrastructure that's like every time somebody sends me a request, make sure that it is a row that has these columns and then turn it into a pandas data frame and then send it into the model and then send it back. And a lot of this is really repetitive. Great at this kind of stuff. Figuring out best practices. It almost goes without saying, but that's exactly the sort of thing you can ask GPT, and I do that all the time. I think what has been an interesting adjustment for me is assuming that's where I should be starting. Like, you can waste a lot of time on web tutorials for stuff that's been around for 10 years. And there's just no point. GPT is going to be able to nail this the first time. Now, if it's something too new, it won't. If something came out in the last year and a half, it's going to know almost nothing. And if it came out in the last 3 years, it will know about it, but it's not going to be the most likely token that follows your question, right? This is where it's useful to think of these things as like pattern recognizers and guessers, because most of the information on the internet was around before the new version of this language or whatever came out. And so it thinks the most likely answers are probably the older things, not the newer things. So sometimes you have to specify. In fact, you can actually see in one of these things I was going to show. Yeah, here I said in Scala 3, how do you do this? Because if I didn't, because Scala 3 has only been out for a couple of years and wasn't in common use during much of the time the GPT is trained on, it would default to Scala 2 syntax. In general, it has seen a lot more of the older stuff, so it leans towards old things. You have to consciously fight against that. Okay. So now we have some more tangible things that we'll move through pretty quickly, but mostly like advice based on those general principles. The key insight is that structure is how these things work. They are pattern recognizers based on the context around the patterns. And so the more context you can give, the better they will do. The thing about structure in programming languages is that programming languages in general are way more structured than human language. And that's why these things work for code. It doesn't make a lot of sense for it to auto-complete your essay as you're typing it, but it does make a lot of sense for code. It can get it right quite a lot. But it'll get it right more often if it has more clues. So the things you want to do are clear and actually small function definitions where you can. Because if you break things into functions and you give the function a name and you give it the parameter names, it will start guessing. Like, what does the linear regress function do? It's pretty obvious. You gave it target and you gave it features, and it knows how to turn that into a model. Especially if you can be consistent in your own code, because there it will start learning that in every test you write, you always start with the same 3 steps. Every time you create a new file, you import the same libraries. These kinds of things, it will get right. It's not saving you from the hard thinking. Just in general, that's the theme of what they do. They're not saving you from thinking hard, they're saving you from typing a lot. And you should think of them like that. Additionally, the naming and patterns common in the wider world, I keep saying like name your functions obvious things, and that does help. Name your classes obvious things, leave good comments. But also, if you start building larger applications, there's really common ways to structure things. So often, if you go and you build like a web API, the tutorial will say, you should put these things in this folder. You should put these files in this folder. You should put these files in this folder. In general, we recommend importing this and setting up your application like this. Follow those directions, at least at first, because it will gather the context of what you're doing and get better at filling it. The more you stray from the beaten path, the less it understands. Lots of people have walked on the beaten path, and it has seen a lot of examples of people solving problems with those. But the more you chart your own path, especially early on, the more lost it'll be, and it'll just start guessing random ideas, like anything that it knows it's ever seen. So you want to adhere to structure within your own code and common conventions outside of your own context. And this really is the main one. A lot of these other ones are just related. In fact, a more specific example of structure is static typing. Has anybody used static type hints in Python? It's where you have like :int. Okay, not a lot. Okay, so I highly recommend you look into it. In programming languages, there are generally 2 classes of languages. There are statically typed languages and dynamically typed languages. The trade-offs there are that statically typed languages require more effort up front. They tend to be a little more rigid, and they actually require a lot of typing in a lot of cases. Then there's dynamically typed languages that are a lot better for working fast and working interactively. So Python, R, most things we see in data science are going to be dynamically typed because they're much easier for someone without a computing background to work through. But they're also, they give less clues about the code. So originally static typing existed to give the computer clues about how to run the code internally. Some of that was for optimization, but a lot of it was because the computer needed to know even how to store the data for you. We've gotten past that point. It's not such a big deal. But LLMs are making it even more relevant because if you have types in your code, you say this is an integer, this is a data frame, as we saw with linear regression. As soon as it knows what type of thing each of your parameters is and what type your return value is, it suddenly understands the relationship a lot better. Like if you were given a data frame in a series, you can understand that that's probably something you can build a model from. Whereas if I had written this linear regression function, it probably will still get it right because it's such an obvious name. But these are the type hints, pd.dataframe, pd.series. If I took those out, and I didn't leave a return value here, I'm not actually sure that it will get this code quite right. It might get close, but we're not giving it enough clues. Let's see. We still are. This is too simple. But in a lot of cases, if you're doing any kind of nuanced thing, or if you're using something non-standard, like imagine if we actually thought a target was going to be a list of integers or something, a list of floats. It's never going to get this one right unless we tell it, because it's very unusual for people to be working with a list of floating point numbers instead of a pandas series. That's more normal. So by adding all these annotations, not only is it nice because it gives you access to some of the Python ecosystem that actually checks your code for you. There's a tool called MyPy that'll do that. Again, highly recommend looking into it. But also, you're going to just speed up the LLM. You do a little more typing on your end, but then it can knock out a lot more of the typing for you. Okay. So one interesting case I came up with was this. So data classes in Python are like really simple objects that just have a couple of fields in them. So a point class, I said, is going to have an integer value for x and an integer value for y. And you can return a distance from a point by just defining this method. I said, let's calculate the distance between these 2 points. I actually said this returns an int. It'll be a float, but it doesn't matter. But just by telling basically by telling the LLM that there's a distance from method, when it tries to write the closest point to function, where I give it an origin point and some other points, it knows that the way to do that is to call the distance from function. If I hadn't given it all these clues of saying there's a distance from function that takes in another point that returns a number, it would not be able to make these inferences. So this is the benefit of static typing to these kinds of problems. As far as I know, R doesn't have anything like this. It's possible it'll get bootstrapped on later, but my guess is this probably isn't going to be popular outside of Python. So if you're using Python, well worth it. It also means that some other languages that might have seemed cumbersome, so Scala is a statically typed language, Go is sometimes used in this kind of data science stuff. Those are a little more worth learning, because this makes them easier to use and actually can make it a lot faster to work with. Yeah.
So the thing after the semicolon, is that just a comment in a way? Is that what that is?
Yeah, good question. So if anybody didn't hear, the question was the thing after the colon, is it a comment? Sort of. So what happens inside the Python program when it runs these things is it sort of like keeps track of these things almost like comments, but then it also can make some additional decisions. It's sort of like metadata attached to all of your variables. So Python itself mostly ignores them. But for example, in VS Code, it'll start giving you hover hints. So if I were to go back to, actually here's a good way to do it. So let's say again, features is a data frame. When I go hover over the features variable, it actually tells me that's a data frame. So it's metadata that other tools can use. The editor can use it, and then there's this MyPy tool that'll go through your code and say, like, based on all the hints you gave me, is your code actually going to break? Because often it is. And that saves you from a lot of bugs. So these are called type hints, type annotations. A larger topic than we have time for, but worth learning. Let me see here. How are we doing on time? Okay. I'll move a little faster through these other ones. Okay, so on a similar note, don't worry so much about not repeating yourself, because LLMs are just going to repeat yourself for you. If you do the same thing a lot, this is Go. I said there's this thing where anytime there's a possible error, you have to write a little bit of code and be like, if there's an error, do this. You got to write this like 400,000 times when you write Go. It's so annoying. But this can make things a lot easier, because who cares? I don't have to write it anymore. Every time I do anything that might return an error, the LLM just says, okay, well, do this and move right along. So don't worry so much about it. Worry a little about it, because it does mean that if you have the same logic in multiple places and you have to come back and update it sometime, then it's just a lot more work. You have to catch a lot more places. But don't worry as much as you might otherwise. It's not the worst thing to have some repetitive sections. We've talked about this a lot. I won't repeat it, of course. Basically, just write out functions and classes with their parameters labeled with types, with good names in ways that resemble the way other people would have written these things in the past. It's just going to help the LLM. Here you see I just wrote the signature for this find file with contents saying I have a directory, which is just a path. A path is a type of object in Python. You can import it from the standard library. And I said if I were given a string, how would I figure out all the, or how would I find a file that contains that string in that directory? And it just wrote the whole thing. We've seen this a few times now. It's pretty cool. Writing test very similar to writing functions. Give it a good name, start setting it up. Sometimes you need to keep hinting the LLM along a little. It won't guess it at first, but if you leave a comment or you start typing the code, it'll get on the right track. You might need to modify it a little, but it can guess a lot. This is a kind of specific piece of advice. I think your temptation, especially when writing tricky code, is to use comments to say like, how would you sort the data frame by the count column? But actually remember, on the internet, where these things were trained, nobody left a comment that was like, how would I do this? And then they like wrote the code, right? That's not how comments work. So remember, you're trying to make your code resemble an autocomplete problem. And so what you instead would say is like, here's some awesome code I wrote to sort the data frame, and then it will spit out the awesome code, right? So you're hinting it not by asking it things, but by like giving it the first part of the sentence and it finishes. So leave comments that are like this, the below code does this. That's a good way to start. And if you really care about efficiency or something, you can even say like the below code does this in the fastest way possible. And it's gonna be like more sensitive to doing it the fastest way possible because other people only say that in that situation. Common tasks, you could just write ChatGPT, just like write the Python code to sort a data frame by its count column, ascending with nulls first. I did this one earlier. And it does this whole thing. And it even tells you like, oh, your request is a little unusual because usually nulls go last, and so what you can do is reassign something else to the null values, and they assign negative infinity to the nulls, and does the whole thing. And it gives a little more explanation after that too. So it's these kinds of relatively one-sentence simple things, it'll just crush. Starting a new project, which is pretty daunting. So especially, if you work at a company where you're not one of the senior people, usually you don't like start the projects from scratch. You're not the one creating a whole new folder of Python or R files. You're going in there and looking at other people's stuff and modifying them. Sometimes you need to do that, and so ask like, what is the best practice for how do I set this up? What files do I need? Sometimes you may want to limit the scope a little bit. So I asked this, and I got all of this, and then I got even some more. It's like, well, there's a lot you should do. A little overwhelming. But even if you just want to pick and choose out of here, or maybe after it responds, say like, I just need a little bit, like what's the bare minimum I can do to get a Hello World program? That kind of thing. It responds well to asking for clarification. Also, I do think this is just funny because as much as I like Python, this is like the minimal Python command line application project. This is all the stuff you need to do, and it actually didn't all fit on this slide. So there is a lot of stuff that goes into getting started with Python. So if you ever feel like it's complicated, you're not wrong. It can get complicated sometimes. In terms of tuning, like tuning I have in quotation marks, when you are getting some code that isn't quite right or you have some issue with it, it's just not going to be right that high a percentage of the time realistically, but it will be mostly right a lot of the time. When you look for what the issues are though, you should not be looking for typos. Remember, like it's trained, it has like seed patterns. It realizes that if you have one variable called silver, it's not going to try to call it sliver somewhere else. Like it's very smart on these things, on patterns. It's not so smart on like what are you trying to do. So sometimes it makes weird implementation decisions, or it misunderstands the task and it goes in a whole different direction. Does instead of building, if you said like I want to build a model, you leave the function name as model the relationship between x and y. There's no guarantee it's going to build you a linear regression. It might build you something else entirely because all you said was a relationship. So look for cases where it's like not understanding what you want and going in a different direction. That's what you should be sensitive to. You don't need to read every word because mostly what you want to check is like, is it basically following the steps I explained? Yeah, you can either modify the code yourself and paste it in chat and have it and explain to chat what's wrong, which is surprisingly useful, especially with GPT-4, where if you say like, this code is not quite right because I'm getting this error, it can sometimes figure out based on the error. Like sometimes you don't even really need to understand the language very well because you can just say, I got this error, now what do I do? And it'll walk you through it piece by piece, especially for common things. Beyond coding, there are big tech decisions you might need to make, especially as you get to a more senior level. So decisions about like what language to use or what sorts of frameworks to use. In general, I would say, you talked about staying on the beaten path. That is more important than it used to be because all of the training data is the beaten path. The more you can stay with standard tools, the more these things can help you. So consider that in your tech choices. But also be open to the fact that you can switch things out later more easily than you used to be able to. If you have a whole file where you do some complicated task in Python and you don't want to rewrite it in Scala, that should be fine now. You can say, rewrite this in Scala for me, and it might get it the very first time. It's a pretty good chance it will. So it's not such a high cost thing to migrate between languages and tools as it used to be. Career stuff. So I think this is really interesting. If your job doesn't let you use an AI coding assistant, it's going to hurt your career, which I think companies are very much in denial about and people are not thinking very much about as individual contributors. But the gains of this are so dramatic that it's almost like, you know, being one of the first people who knew how to use a calculator, except the calculators are a little easier than this. You know, there will be very few jobs will be willing to let you not use this. You will just be much worse than other coders if you don't have these tools at your disposal. And while they're not impossible to learn, like anybody can go and just type in ChatGPT, some of the advice in here is what you need to start having immediately at your fingertips to say, like, I know how to use it for this, and I know not to use it for this. Be a little bit smarter on those kinds of things. So keep that in mind. When looking at jobs, I would just say that should be a question you ask. Do you use Copilot? Do we have access to ChatGPT? Things like that. Right now, it's early enough that most companies are not doing that, but keep in mind that that should be changing fast over the next year. Big companies will be the last. Small companies will be the first, as is often the case. Hiring and management. So your interviewing when looking for candidates needs to be even more oriented towards whether those people can solve difficult problems and work through challenges. Not about, do you come in knowing Python? Do you come in having worked a lot with Spark? Because these AI tools can get you up to speed on new things very quickly. They won't make you an expert, but they will make you competent pretty fast. And so really it's kind of nice. It's kind of like moving up the ladder of intellectual jobs. Programmers more and more are going to be thinking about how to solve difficult problems, how to turn business logic into something that looks like code, whether that's like talking to the AI assistant to do it or actually writing it. But so much of the standard code of like setting up a basic data pipeline, like that stuff is just too easy to automate. That's going to be done by the assistant mostly. So you don't want to be hiring people based on their very specific skills. The other thing, obviously, complement to the last slide, is you really need to get these tools approved for your teams. This is a corporate security nightmare, honestly. Like, big companies hate this stuff because it's sending information over the internet. Everybody's inclination who doesn't work in development is going to be to say no to this. But you're going to really hurt the prospects you get, and you're going to just enormously slow down your pace of development. So anybody in a decision-making capacity in the development and data science department needs to be fighting for these tools because otherwise they will never get implemented. And maybe that goes without saying, but that is going to be hard work, I think. Okay, and we'll breeze very quickly through AI weaknesses because we're out of time. So we already said new business logic, it's terrible at. So imagine you write a function that's like compute the price of my order. And I said, okay, well, let's say for each of the items, look at the item name and do something. Well, it just guessed like bananas cost $4.50 and apples cost $5. It has no idea what's going to go in there because this is logic related to my shop. You know, it has no idea how to do that. It might even slow you down because it's annoying. It keeps popping up in your way. It's biased towards older tech. We talked about that issue as well. It's generally going to try to give you examples of older things. And for really new things from the last couple of years, it hasn't been retrained since mid-2022. So you're just not going to get anything that can help you with that. Garbage in, garbage out. If you don't structure your code well, or if you don't explain it well, or if you give bad names, it's going to have no idea what to do there either. And last, just kind of on a personal note, it's just kind of a bummer that I think we're not going to code this. It's very sad. But I really like coding, as you can probably tell, but it's not going to be the same. And realistically, this is how stuff changes. It's a little bit like a stick shift. I think people are sad that stick shift cars are gone if they used to like them, but it's definitely just better. I realize people have an attachment. I have an attachment right in my own code because it feels really fun, but this is way more productive and this is the way everything's going to go. So while if you work at some ancient institution, they might not have this, everybody else is going to. In general, the norm will be that you use these assistants for everything and you work a lot faster. And it will eventually lead to productivity gains, not losses, because every individual programmer gets a lot more productive. And it's generally a recipe for economic success. So, I don't know, maybe you don't have to embrace it, but you have to accept it. And the last thing is internet reliance. You can't do these without the internet. Yeah, it was really Coding on a plane, not so good anymore. Okay, so just to wrap up, chat, autocomplete are changing the game. They cost something in the range of like 10 to 30 a month. Copilot is $10 a month, ChatGPT is 20. I pay for both of those happily. I think I would pay 3 times as much at least. I probably, if I were smart, would pay even more than that because they're just they're so useful, especially if you're using them in a business setting. These assistants thrive on structure and clear descriptions, following patterns, doing things other people have done before. And so you want to lean in that direction wherever you can if you're trying to maximize them. And last, in like a corporate sense, invest in them. As an individual contributor, make sure you're learning these, getting accustomed to using them day in and out so you're actually using them effectively. And as a manager, get them approved and hire for people who are good at other skills. That is all I have to say. Thanks. So, does anybody have questions?
So what's the pitch to get security to approve these?
Well, I think, as with most things that I've seen in corporate environments, you're not going to convince security. You have to convince the level above security. Like, you have to make the case that the benefits are too large to pass up. And I think really what I would recommend in that situation is make some estimates on the percentage speed up you're getting and say, like, either we could have, and I don't think you should lay off 2/3 of your developers, but the idea that either you could get 3 times as much done or have 1/3 as many employees, for example. It's like that cost vastly outweighs most of the security situations.
So you're kind of saying, like, you're admitting that it is kind of insecure, but it doesn't matter?
No, I think I think actually it's very secure, but it's much like the move to cloud computing a few years ago, where the thing companies don't like is that, you know, if you work in AWS, Amazon has to get your data. There's no way around sending your data to Amazon. And Amazon has all these documents that says we can't look at your data, it's stored in this way, it's all encrypted, we have all these safeguards, but companies are just wary of that. And these same things, if you look at I pulled it up recently, but if you look at the Copilot terms of use, they don't store anything, they don't retrain on the data you send. And so I would feel good about it, but I know corporate security has very different standards than I do. So you have to make an overwhelming case that the benefits are too large and you have to accept the drawbacks, which is exactly like the cloud transition.
Gotcha.
So I would compare it to that, actually.
Thank you.
Yes,
So have you used any of the open source equivalents,
I haven't.
like StarCoder or something?
Yeah, I have not used the open source equivalents. I think some of them can be run locally, which seems like a nice pitch. But I do think the developer experience is just so good to open VS Code and it's just like logged in and set up. I don't know, something I'll be keeping an eye on. Yeah, it's possible to catch up. Yes.
I'm curious, like, you talk about like the bias towards old tech, and I feel like there's been a shift, not just in like new tech, but new, like, the best practices have been evolving.
Yeah.
Like the big one I've seen in the past 5 years is like a huge shift from stateful object-oriented to stateless functional code, and like, have you run into cases where it's suggesting something and you're like, I don't think this is actually best practice anymore, but there's so much code that people have written.
That's an interesting question. I think in general, I want to think about that a little more deeply. But I will just say, at a high level, it really favors more stateless code because it doesn't really like writing classes because they're too big. It doesn't make such large guesses. Like what we were seeing is we get like 8 lines at most, so it's very good at functions and very unlikely to write you an entire class that has stateful things. So, and also I've used it a lot on some languages that prioritize statelessness, so like Go and Rust, and so it hasn't come up as much. So I don't have a great answer to that. Yes.
Yeah, we've seen before that tech companies sue each other. Somebody infringe their own IP, write part of algorithm
Yeah.
code. With this, I mean, will they lose the right to claim their IP on the?
So you're saying that their IP, they would claim their IP is being infringed because their code was trained upon?
Well, in the past, somebody used another company piece of code and they're suing each other. Similar things right now. I'm using other people's data to help me write the code. Can they claim 100% IP on the code I write using a system from others?
Yeah, you know, that's a good question. I think that is not, it's not clear how it will be settled, but it does seem like we're fighting this battle mainly with art right now of like what is AI art, and a lot of artists are suing and some authors are suing about their works being used in GPT. But nobody who uses the GPT output is being sued, I think is relevant. Like that doesn't seem on the table. It's possible we will see some new standards around how these models have to be trained because OpenAI will have to pay some huge settlement to authors or something. and then we'll only be using free stuff on the internet. They won't be able to use books or anything. But I think the chances of it like trickling down and negatively impacting the usage of these tools is pretty low. Because all you would do is use things that are public domain. So on GitHub, there's loads and loads and loads of things with like an MIT open source license that say you can do what you want with this code as long as you don't. And I think like copy is not one of the things you're not allowed to do. So there's no question we would be allowed to train on MIT licensed codes, on like the GPL, which is another license. So I don't think we're gonna end up in a situation where it's like we have legal reasons we can't improve the models. That seems very unlikely.
Okay.
None of this is trained on closed source code, right?
Okay.
Like none of these were on secret corporate projects. That's not in the training set.
Parasite, right?
What's that?
OpenAI has some copyright content because they crawl the parasite, which
Yeah.
has
Well,
the
yeah.
source.
That is true. So GPT, I think you're right. ChatGPT has more concerns here because they did use just the broader internet. And I'm thinking more about GitHub Copilot. But Copilot is made by GitHub, who has access to all the licensing files of every single repository on the service. And that's what they use to train. So they have the metadata to say, okay, if people say we're in legal trouble for doing it this way, we're just going to retrain all over again, but only use the open source ones, which I think is actually what they did, but I don't know all the details. So this is ultimately like, I don't know the legal ins and outs, but I have a hard time not seeing this be dominant one way or another. Like I think it's just too powerful, and even if we have to limit the scope of some things, it's still gonna be around in some sense.
Yeah, another thing we're concerned about the code contamination, right? Unlike other pieces are self-contained, but this one, usually you build one set of code on top of others. If one set is contaminated,
Yeah,
it's gonna spread out through the organization and you can't clean it up.
that is true. I think, yeah, we just in general see ripple effects as being really meaningful. But that's also why, I mean, so much of the work that OpenAI does is essentially like filtering out content, because it's the same issue. When they, like, the idea of contaminated code is not that different from like, you know, really dangerous content on the internet that gets spit out by GPT. So they're constantly like trying to find ways to filter that out of the model. But they'll never, probably never get it gone, so. Yeah,
Do you predict in the future there will be a need for less programmers because of the productivity gains from using these kind of assistants?
I'm skeptical of that, but I think honestly that question is like so, whether productivity increasing tools are gains or losses for labor is like a way more political and economic question that I think is hotly contested. My suspicion is that it probably is good, especially in these kinds of fields, but I don't know if that's settled. And probably not something I can really weigh in on helpfully. Yeah. Yes.
There's two things that seem to contradict themselves that you said. Maybe you can clarify.
Okay, that's possible.
The first is that if you work for a company that doesn't do generative AI, it's encouraging. And the second one is you're gonna get worse at coding if you work for a company that does generative AI.
Yeah.
So it almost seems like it'd be better to work for a company that doesn't have generative AI, because you don't need to be as productive and you'll get better at coding.
Yeah, I see what you're saying, and
Is that,
no, well, it does make sense. It does make
Okay.
sense, and I should be clear. It's that I'm using the word coding in two different contexts. You will get worse at the way we think of coding right now. But you will be a more productive employee. That's the thing, right? You will be more productive at generating business outcomes and less good at remembering the 4,000 functions available on a man's paper. Like that's really it. And I think you'll feel less fluent, but you're actually writing way more code, even if you're not the one writing all of this. Does that make sense? It's like you're worse at the current skill of coding, but the current skill of coding is not what it's going to be a software developer or a data scientist in 5 years. Yes.
Hi, oddly enough, we are offering generative AI for the first time in the spring semester for our students here as an
Cool,
elective
nice.
in the MS BANA and MSIS program. So it's just really interesting to me as a co-program manager to see that you're presenting this and how
Yeah.
impactful it is to where we're at and where we're going.
Yeah, I hope everybody tries to sign up for that. I hope you have a lot of seats. Very worth doing. Yeah. Great.
Can we give another round of applause? Please fill out